Hey guys, welcome to our next video. Today we're going to be talking about some different substances right here, and I don't want to give away the topic yet. So we have ammonia, apple juice, milk, lemon juice, vinegar, soda, shampoo, water, bleach. So obviously right away you could say, oh, these are all household items. All right, that is true. So they're definitely household items. Some other things you can say is some of them are cleaning products and others are food items. So that's a kind of interesting observation there. But definitely one thing that's true, some of them are more dangerous than others. So we'll talk about how to talk about these objects a little different way than you're normally used to. All right, so let's talk about this in a chemistry way. So we're going to talk about acids and bases. All right, because each of those things on that list are either an acid or a base. So I'll return back to this list and talk about what's an acid versus a base. So determining the difference between an acids and base. So obviously everybody thinks of an acid, they think of lemons. Lemons definitely are sour. Good example of that. Water is kind of an interesting substance. It's neither an acid or a base. We'll talk why that is and where it falls. And then milk is actually slightly acidic. A lot of people think it's a base. It's really not. So it's slightly on the acid side, but it's a weak acid. Okay, so pH scale measures how acidic or basic a solution is. So 1 is considered to be very acidic. 14 is considered to be very basic. And if you're in between, it's usually it's a weak acid or a weak base, which falls in between there. And then there's also a neutral number, which we'll talk about in a moment. All right, so here is the pH scale. So to give you an idea, remember it goes from 1 to 14. Really 0 to 14, but nothing's going to be 0 on the scale. Something will be above it. Stomach acid is 1.5 on the acidic scale, so it actually is very acidic. Lemon juice is 2.5. Tomato juice is 4. Now, as we go up the list here, these acids are getting weaker and weaker. Normal rainfall is a little acidic, depending on where you live, obviously. We tend to have very acidic rain because we have a lot of pollution. Milk is also slightly acidic, as I mentioned. So here it proves it. It's actually a 6.5 on the scale. Neutral is the middle, which actually is pure water. So water is right in the middle of the scale. Seawater, on the other hand, that's actually slightly basic. So that's a weak base. Soap is basic, right? And it's like 10 on the scale. Ammonia is around 11.5 on the scale. So that means it's pretty basic. You know that's cleaner. It's actually in Windex. It has definitely an odor to it. These cleaners here are very strong and they tend to have very strong odors. Bleach, you know that one too. Again, make sure you wear rubber gloves when working with that stuff. And then oven cleaner is very basic, right? Very strong cleaner. Be very careful with that if you ever clean your oven with it. Okay, what do these compounds have in common? All right, so if you look here, quick answer is they all have this hydrogen. Okay, having a hydrogen in front typically means they're going to be acids. All right, so HCl, hydrochloric acid, hydrobromic acid, HBr, HNO3, H2SO4. Those are all different types of acids. On the other hand, bases, which all are going to end in OH. All right, so you see this little OH group on the end. They tend to be basic. So just showing you that on that slide. Okay, so how do we identify them? So again, acids have a pH from 0 to 6. Lower pH indicates a stronger acid. So a little different than what you would think. A higher number is actually a weaker acid. Bases have a pH from 8 to 14. And higher pH value is a stronger base. So closer to 14 is a stronger base. A weaker base is going to be closer to the number 8. What number do we leave out? Obviously the neutral number. So I mentioned already, pH of 7 is considered to be neutral. So water is in the middle of the scale. It's neither an acid or a base. It just kind of sits in the middle. It has to be pure water because when you start adding stuff to water, it actually changes its properties a little bit. Okay, acids are characterized by the following properties. Okay, it has a sour taste. So acid food or acidic food like vinegar, you guys know, is very sour. Also, tests that we do, all right, something called a litmus test, litmus paper. Blue litmus will turn red, and that's an acid indicator. So remember, red acid. Obviously, if we put red litmus in there, it would stay red also. Okay, and you guys also know if you get basically lemon juice on a cut, all right, even the biggest a person, it hurts. All right, so acids will burn if they get into open cuts. So just be careful, especially even with food items. If you get them in an open cut, it won't feel good. All right, bases, on the other hand, they're also very dangerous on the far end of the scale. A bitter taste. So milk of magnesia is something we use to settle our stomachs when we're not feeling well. So that's a base. Because stomach acid is very acidic, so we want to calm that down sometimes. Feels slippery. Soapy water is an example of that. So you know that feeling. If you work with bleach or ammonia, you're not supposed to touch it with your hands really, but you'll feel it actually feels slippery in your hands. But if you get it on your hands, you should wash it off immediately. It can eat through your skin and damage your skin. Also, the indicator for bases, red litmus will turn blue, and blue litmus will stay blue. So that's the test for an acid or a base. If you had a neutral substance, the red litmus would stay red and the blue litmus would stay blue. All right, so that's definitely something to know with that. So bases will turn blue, base blue. We also use these. You guys may be familiar if you have a fish tank or if you have a swimming pool. There's test kits for that because we don't want the water to be too acidic or too basic for us or the fish if we have a fish tank. So we have to be very careful keeping these numbers in check. So basically the little test kits, what you do is you put the drops in if they require drops, or there's little dipstick sticks like this one here. You dip it in the water and then match it up to the scale. And when you match it up to the scale, it'll tell you the pH. And there's different color codings for different range of pH. So make sure you have the right one for your particular situation. If you have a saltwater fish tank, you have to use a high range pH kit. If you have a freshwater, you use just a regular standard pH kit. And then pools obviously have ones that are calibrated to the pool numbers. So make sure that you guys keep your numbers right on those. Otherwise, again, damage to your skin or damage to your fish. Why learn about them? So pH level of tap water, you guys know, is neutral. pH of the swimming pool must be checked periodically. The reason why, we don't want to burn our skin. We don't want to burn our eyeballs when we're in a pool. So we have to be careful. And we don't want algal growth also, because if you have the pH on the lower end, you tend to have algal growth, and that's why we put in chemicals and whatnot to keep this in check. Important for lakes and rivers to maintain pH also because fish live in there, and fish also cannot survive when the water is acidic. And you guys know acid rain tends to occur, and that acid rain will go into the lakes and rivers, and the fish can't live in that type of environment. As far as you with acids and bases, skin contact is a big concern. And again, exposure to either acids or bases that are on the far ends of the scale can cause major damage to you. Concentrated bases cause deep, slow healing wounds. And this happened to me once. I was working with my dad. He used to be a tile man, and I had to grout a lot. And I ended up grouting with this really strong grout called lime. And basically, I got it on my skin, and it started eating away at my skin. And it was actually painful, very painful for days. So you have to be really careful. I was wearing gloves, for the record, but it ended up getting inside the gloves. So it was kind of unavoidable a little bit, but definitely caused some damage to my skin. Acids, on the other hand, these will damage your skin immediately. So acids will react with your skin not over a long period of time, short period of time, and may be irreversible at the site of contact. So that you'll see these danger acid corrosive signs. They're not joking. That stuff can burn through your skin pretty quickly. There's some that will eat away at your skin in seconds. Hydrofluoric acid as an example, and it actually goes through bone also. So you would need something to neutralize that immediately if you ever worked with that. And obviously you can't get that in a school, but definitely it's a dangerous stuff to work with. Even hydrochloric acid, which we use that sometimes in pool situation. Muriatic acid tends to be it can burn through your skin pretty quickly. So again, be careful working with this material. The litmus paper test. So again, to go over this, so a base, the red litmus will turn blue. Blue equals base. Acids, blue litmus will turn red. So red equals acid. And if it's neutral, no change in either litmus paper. And also you can confirm this with the pH test strips. But this is the questions they tend to ask. So these are the simple indicators of pH. And just to return back to this list, so you already saw these. So that's it for today, and I'll catch you guys next time.